Hello everyone. So in the previous presentation we discussed about the voltage and current, that how a current exists in the wire when we connect a conducting wire across the terminals of the voltage source. So there are some questions which arises in everyone's mind when we connect a conducting wire across the terminal of the voltage, that what determines the level of current when we connect a conducting wire across the terminal of the voltage source, and why is the current heavier in some circuits than in others? So the answer to these questions is simple, because there is opposition to the flow of charges. When we connect a conducting wire across the terminal of the voltage, then there is opposition to the flow of charges inside the conductor, and this opposition to the flow of charges is known as basically the resistance. So we define the resistance as the opposition to the flow of charges in an electrical circuit is known as a resistance. So this resistance is used to limit the flow of current or the flow of charges inside the conductor, and the device which is used to produce a resistance in any circuit is called a resistor. The unit of resistance is ohms, and which is represented by a Greek letter omega. The graphical symbol which is used to represent a resistance is like the cutting edge of a saw, and there is other symbol which is also used to represent a resistance is like this. But in most cases this symbol is used. This figure represents practical resistance which is used in any circuit. So basically this opposition to the flow of charges is due to the collision and friction of electrons with other electrons, and also with the ions and atoms which came in the path of motion of these free electrons. So this opposition is basically due to the collisions and friction of free electrons with other electrons or ions and atoms which came in the path of motion of these free electrons. So due to this collision and friction, electrical energy is converted into heat, which raises the temperature of electrical components as well as the surrounding. The electrical heater is the simple example. The electrical heater is the simple example of resistance. The heat which you feel from the electrical heater is due to the current which passes through a high resistive material. Every electrical material reacts differently to the applied voltage because of its different atomic structure to pass the current through its core. So basically there are two types of materials. The one is called a conductors, which allows a generous flow of electrons, a generous flow of electrons through its core. And there is another material which is called an insulator, which stops the electrons flow. So we can say that the resistance of a conductive material is very low, and the resistance of an insulated material is very high. So the four basic factors which shows the resistance of any materials are, in which the first one is a material, and a second one is length, and a third one is area, and the fourth one is the temperature. So material is identifying the sort of material which is used in the circuit, and we can identify the type of material which is used in the circuit by a factor called resistivity, which is represented by a rho. rho. So greater the resistivity of the material, greater will be its resistance. And the length identifies how long the path of the current is. Greater is the path of the current, the greater will be its resistance. And it is represented by L. And the third one is the area of the conducting material. So greater the area of the conducting material, less will be its resistance. And the last one is the temperature. So if we increase the temperature of the conducting material, so the vibration and the collision between the free electrons and atoms ions will be increases, as a result of which the difficulty to the free electrons to flow inside the conductor will be increases. So as a result, the resistance of the material will be increases. So we can relate these three elements by the equation R is equals to rho L divided by A, which represent the resistance of any material. So if we increase the resistivity of the material, the resistance increases. If we increase the length of the material, the resistance also increases. So if we increase the area, then the resistance will be decreases. So let's move on towards the types of resistors. So basically there are two types of resistors. The first one is a fixed resistor and the second one is a variable resistor. So as the name suggests, the resistor which has a fixed value is called a fixed resistor, having a fixed value which doesn't change. So there are varieties of resistor which has a fixed value, in which the simplest one is film resistors, which is shown in the given figure. This one is basically a thin film resistor, and this types of resistor is used most in the circuit. And the symbol for the representation of fixed resistor is the same as that for use for the definition of resistor we used earlier. There are two main points that is basically you need to remember about the fixed resistor, in which the first one is, in a particular style or manufacturer, the size, by increasing the size of the resistor, the power or wattage value of the resistor will be increases, which means that if you increase the size of any resistor, the power or wattage value will be increases, but it is not affect the value of a resistance. Look at this picture, in which we have 5 different size resistors, each having a different wattage or power value, but the resistance value of each resistor is the same, which means that if we increase the size of a resistor, the power wattage or the power value will be increases, and there is no effect of the size on a resistance value. So moving towards the variable resistors, in which, as the name suggested, a resistor having a variable value, or simply we can say that the type of resistors whose terminal resistance can be varied by tuning a dial or a screw. The variable resistors may be having a two terminal or a three terminal. But most of the time we use the 3-terminal resistor as a variable resistor. And a 3-terminal device, the 3 or 2-terminal device which is used to control the resistance of any material or circuit is known as a rheostat. And the symbol of a rheostat is like this, in which the 2 terminals are having a same value and there is another terminal, let's say B, which varies the value of the resistance as needed. Or the other symbol which is represent the rheostat is like this, a simple resistor having an arrow. This is also used for the representation of a variable resistor. Point AB will represent the resistance between A and B, and point BC will represent the resistance between point B and C. If this 3-terminal device is used to control the potential difference, then it is called a potentiometer. And the symbol which is used to represent a potentiometer is the same as that of a rheostat, but the only difference is here we have point B. Here the point A and B will represent the voltage between A and B, and point B and C will represent the voltage across B and C. Here the resistance between point A and C is the same for all the cases, but we can differentiate or change the value of resistance by tuning this point B. Let's say, for example, if we have the total resistance between point A and C is R, then the total resistance between point A and C will be equals to, due to this knob, RAB plus RBC. So it's all for today's lecture. In the upcoming video, we will be discussing about the color coding of resistor and the range of commercial resistors. So see you in the next one.